Hello, today we will do Cambridge IGCSE Additional Mathematics Syllabus Code 0606 May June 2025 Series Paper 2 Variant 3. Alright, so before we start or before you play the video, you can try the questions on your own time and then you can go along to try to check your answers. Question 1 is a quadratic inequality. So they're already given you in a factorized form, right? And what you can try and sketch it looks like this. And from this factorized form, we can straight away give the critical values as critical values, which is the roots, right? Critical values. You have x equals to -2 and also x equals to 5/4. So what our graph look like is here will be -2 and 5/4. So we want the region for x where the y value is less than 0. So meaning our graph is lower than the y-axis. To satisfy this inequality, our x has to be in between these two values, right? -2 and 5/4. So that's the region where x satisfies this y inequality. Okay. Next, given that y is this function, so show that dy dx can be written as this. Okay, so if you look at this, is a quotient, so we definitely have to use the quotient rule. If you recall the quotient rule, if you have you take the derivative of a quotient, then you have take the bottom up first and then differentiate the top function minus. Okay, so minus, that's why the order is important. You leave the top function, differentiate the bottom function, and the bottom function you square it. So in this case, let's try and do this with our function. The bottom function, I will take it up and leave it first, and I'll differentiate the top function, which get 12x squared minus of, I leave the top function for x cubed minus 5 and differentiate the bottom function, get me 2x. The bottom x squared, then square it again, so it's x power 4. Now we try and simplify this. Okay, how to simplify this? By we can try and take out, or from the numerator, I'll try and factorize factorize x out of the entire equation, or even better, I'll factorize 2x out. Right, 2x I'll take out. So this x and x power 4 you can cancel, and I'll simplify inside here. Left with 2x cubed plus 5 and then x power 3. So therefore I have shown it. Okay. Question 3. There are two variables such that square root of y is plotted against x cubed, and the straight line graph is passing through these 2 points. So find y in terms of x. So we know that these two variables are related in this type of way. Okay, this is the big Y and then this is the big X. So it's a linear law question. And let's try and find this what we call gradient. Find the gradient already, then we can plug it through the straight line equation, right? So gradient is the change of y over change of x. Get 2, right? 16 over 8, so that's 2. And so now that we have a gradient, we can plug it through the straight line graph, right? Straight line equation, sorry. So in this case, I'm going to use big Y instead of the usual Y, because we straight away plug in as in these variables here. So it's big Y and big X. And which big Y and big X is respectively square root Y and x cubed, right? And we plug it through any one of these points. So I will choose 2, 5. Okay, so these points are already presented as x cubed and then square root y. So do not, okay, a lot of mistake happen when students try and they go and cube the x or they go and square root the y again. Don't do that. It's already presented in this form. So we just have to plug it into the equation. So big Y will be equal to 2x plus 1. And therefore, big Y we replace it as square root y, big X we replace it as x cubed plus 1. And that will be okay, not done yet. Okay, find y in terms of x. So we want to get rid of the square root, and so we square both sides. Y is 2x cubed plus 1 squared. So that will be the final answer. Right, the function f is defined by 2x minus 1. So it's a linear function. And explain why this f power of 2 or f squared can be formed. Again, f square means what? F of x. So it does not mean the fx you go and take and square it. It's a two different thing. Alright, so in this case, f square like this, just seeing f square like this without the bracket outside, you can just assume it to be f of x. So why f of x can be formed? Because the inside function, which is fx, and the outside function, the domain and the range match, right? What is the range of fx? So the range is also all real values. Okay, fx is all real values, and all real values fits within the domain of the outside function. So how you're gonna write is that domain of fx fits, or sorry, the range of fx. Okay, the range of fx fits the domain of fx. So therefore, only then can the function exist. Now we want to sketch the graph of f2x or f powers 2x. Okay, modulus. Okay, modulus of it. So first, let's find this one. F2x is f of x. So we want to get f of 2x minus 1, and then we replace it again, 2x minus 1. Minus 1. So altogether you get 4x, and then minus 3. And we modulus it. Okay, so the coordinate axis, definitely we have one at -3, the original graph, so we flip it up to the positive 3. Then for the x-intercept, y equals to 0, we are going to have 3 over 4. So our graph, for modulus graph, you know that it's going to look like a V shape, and draw a straight line with your ruler, okay, in the exam. Then you label y equals to modulus f squared x. Okay, please use ruler in your real life exam and try to make it as symmetrical as possible. And then what we have, what else we need to do is label the axis, which we have done. And it's given that f square or modulus f square x is less than or equal to ax plus b for this interval and no other values of x. Find the values of a and b. So, okay, let's say we have this ax plus b, that is a linear function, another linear function, which is not modulus. So I'm gonna sketch out, let's say it's just some type of graph or a straight line graph. It looks something like this. We don't know what it is, but it's just a sketch, right? Okay, so okay, maybe you can sketch it more accurately because we know the x values for this is true. 1 and 3. Sorry, -1 and 3. So -1 somewhere here. -1 and 3 maybe somewhere here. Okay, so the graph will look like this. Okay, where this modulus is less than. So less than is below this straight line graph for this two interval or this interval. So find the values of a and b. Okay, let's try and do that first. We probably want to find these two coordinates where they touch. Then we can use that to find the gradient of the graph. And once we have the gradient and the coordinates, we can find these two values, right? So first of all, let's try and we'll do the substitution for f square of -1. So now we have our two coordinates, -1, 7 and 3, 9. Then we can find the gradient, which is a. Okay, a is the gradient. Okay, again we have a straight line graph, y minus y1, m x minus x1 through, just pick any one of these points is enough. So maybe we choose -1, 7. Okay, so we have gotten A is 0.5 and B is 7.5. Question 5. All angles in radians for this question. Write down the period. Okay. For a tangent graph, with what we call the frequency or angular velocity. Okay, maybe usually you have a tangent graph A tangent bx plus c. This one we call as the frequency or something, right? So if b equals to 1, the frequency equals to 1, then the period t, that will be equals to pi or 180 degrees. Now b equals to 1 over 4, so meaning our period will be 4 pi. Okay, so just to write it down, period is 4 pi. That's it. On the axis, sketch the graph. Okay, okay. So quite a long time they did not ask us to sketch a tangent graph already. So first I've seen in quite a long time for this period or this interval of x. State the intercept, okay, and show the position of any asymptotes. Okay, first try and remember how the normal tangent graph, just tangent. It look like this, Then you have asymptote at pi over 2. Then you go from down again to up. Okay, you start from 0, pi over 2, then pi. So there is one period of the tangent graph. It looks like this. It's just one. Okay, so for here we have a period of pi over 4 pi. Then we have a vertical shift of 1. The amplitude, okay, in your syllabus it doesn't really matter because it doesn't really reflect in the drawing. So always for this type of graph, we sketch the center line first. So in this case, we sketch as something above the x-axis and we label it as y equals to 1. And we use this as our baseline now. This is our 0. And where does it intercept with the y-axis? So it's intercept here. And where is the first asymptote now? First asymptote will be at 2 pi. Because one period is 4 pi. So the asymptote will be at half of the period. So we also sketch that asymptote at 2 pi. This is x equals to 2 pi. We also have another asymptote here at negative 2 pi, which also we sketch it. Asymptote I sketch with dotted line. Now we try and draw the shape of the graph. Right, so it looks something like this. Then we don't touch the asymptote. We're going downwards also. Okay, now from 2 pi to 4 pi, going from downwards to up. And we touch it at 4 pi. Okay, so that's it. We only want from negative 2 pi to 4 pi. And also we doesn't need to, okay, we don't have to state the intercept with the x-axis, so we don't have to calculate that. We just need to state here, this is y equals to 1, right? And this is our center line. Okay. Question 6. 5 digits are used to make, or 5 of these digits, so 9 digits here, are used to make a 5-digit number. If this is greater than 5,000, how many ways can we arrange this? So obviously for numbers, the order matters. So we're going to use permutation. And right, if for greater than 50,000, 5-digit number, the first digit can be 5, 6, 7, 8, 9. So out of 5 digits, we need to choose one. So 5p1 there because order matters. Then for the remaining of these 4 digits, if we choose one already, so that's one number out. Out of 9 digits, we still have 8 left. So we have 8p4 here. So 5p1 multiplied by 8p4, you get 8,400. Part B here are if a group of 13 people, 7 have red hair and 6 have brown hair, and they stand in line for a photograph. And no person with red hair can be standing next to another person with red hair. Okay, so essentially what we have, right? So essentially what you have will be they'll have to stand alternatively like that. And then the brown hair people, yeah, the brown hair people will have to stand in between like that. So what we can treat them is their positions are fixed already. Their positions are fixed already, so we can treat them as a lump together. So R and B, like red and brown. And in these two, or like this uh a red situation, they have 7. So they can be arranged 7 factorial ways, and the brown hair people, they can be arranged as 6 factorial ways. And we multiply them, we should be able to get 3,628,800. So these are 3 million something ways to arrange them like that. Chris chooses 5 people from this group. Find the number of ways Chris can do this if at least one chosen has brown hair. Okay, you can do the cases where you have one person brown and four red, and 2 brown, 3 red, and so on and so forth, right? Until you have all 5 is brown and no red. So another way to do this is you can find the all of the possible ways you choose. So if you just choose people, the order doesn't really matter. So we have all the possible ways is 13 choose 5. And then we will take away the cases where we don't want. So the cases we don't want is that where all we don't want the case where there are no brown hair people. Yeah, no brown hair people. So it means all red hair people. So if all is having red hair, there will be 7C5, right? Yeah. So all these are all possible cases. And then this one is all red hair. Okay, so if we take away those cases, so the remaining cases, they will have at least one brown hair people. And we get 1,266 people ways to arrange this. Question 7. Find the term independent of x in this expansion. So let's look at the power, how it's arranged here. Let me rewrite this as x power negative 4. And I will just look at the x terms. I'm not going to look at the coefficients, so that I can just look at the power. So remember that the binomial formula, so the sum of r equals to 0 to n, a plus b power n is this one. We have n choose r, a power n minus r, and b power of r. So this is the binomial theorem formula. And if you don't remember it, it's up here. Okay, this is the expansion formula. Now we want to look at this a and a multiply b. How does the x affect it? So x power 2, then n minus r. That's our a. That's our a term. For b, I'm just going to look at the x. Okay, the x power negative 4 power r. N we know in this case that is 15. R we want to find. R is the one that we want to find. And we want this to become independent of x. So we want the x power to be 0. So we expand this. Right, and then since it's same base on both sides, I can just equate this. So r we get as 5. So in this r equals to 5 term, our x will be eliminated and we're left with independent of x. So let's see when r equals to 5, then we use the binomial expansion formula. Okay, so just as we can confirm here, x power 20 and x power negative 20, they cancel out. And we are left with 3003 multiplied by 243, which we get 729, 729. So what a nice number. And part B, in this expansion, the coefficient of x power 3 is 7 times the coefficient of x squared. So given that a is a positive constant, find the value of a. Okay, so when x power 3 means our r, r will be 3. When r is 3, we use the binomial expansion formula again, n93. Okay, then for x squared term, there will be r equals 2. And the question says that the coefficient of x cubed is 7 times the coefficient of x squared. So we can equate this using that relation. So 84a cubed is 7 times of 36a squared. And so we have some equation to deal with. Okay, so we can immediately factorize this a bit by taking 84a squared out of the equation. Yeah, we factorize it like that. And we have two cases. A can be equals to 0 or a equals to 3. But in the question, we already given that a is a positive constant. So we must reject the 0 case. And we are only left with one answer, a equals to 3. It is given that y is a function and use calculate to approximate the change. Okay, approximate change, if you recall what's the formula we use, the delta y over delta x, we can approximate as dy dx, because let's say we have a curve, then we have going from x to x plus h, where the h is the delta x, right? That's going from here to here. The y will change accordingly with delta y. How do we approximate this? Is with a straight line. And the gradient of the straight line, we find it with dy dx. Okay, because dy dx, again, essentially what the derivative is just the gradient of a curve. So first, let's take the derivative, dy dx. In this case, it's a product of two functions. So remember the product rule. You may leave the first term, differentiate the second term, add, differentiate the first term, and leave the second term. So I'm gonna leave the first term first. Differentiate tangent x, we get secant square x, and we add, differentiated the first term. Okay, exponential function, um, when you differentiate, you don't do anything, but you differentiate the inside function and you multiply by that. So then we leave the tangent x, so we did not differentiate that. Now, we want to find the approximate change at 0.1 to 0.1 plus h. So we evaluate it at the point where x equals to 0.1. Okay, so for any calculus application, please remember that your calculator or any trigonometric thing that you do for calculus should be in radian mode. So reminder to put your calculator in radian mode to calculate this. So essentially, we also don't need to get a exact value for this thing, as in real life also most of the numerical approximation we just give it to some number of decimal places, and we should be able to get 13.1 from substituting the values, after which we can finally do our approximation. So change of y, change of x will be approximately to be dy dx, and therefore the approximate change of y will be dy dx multiplied by the change of x. And change of x, we know that's just h. So 13.1 times h, we get this. Okay, moving on. Part B, we have a curve with a gradient of sine 3x plus pi. And the curve passes through the point pi over 9, 4 over 3. We want to find the exact y coordinate of the curve where x equals to 5 pi over 12. Okay, so let's first find the equation of the line. So y can be the integral of dy dx with respect to x. So we integrate sine 3x plus pi with respect to x, and we'll get a negative cosine 3x plus pi, and we divide it by the inside function, the derivative of the inside function, which is 3. And we have to add an arbitrary constant because it's an indefinite integral. But we can solve for this arbitrary constant because we are given the initial condition of pi over 9 and 4 over 3. So this we can just substitute into our equation, after which you should be able to get your arbitrary constant as 7 over 6. So your the equation of the curve, you get a third cosine 3x plus pi and add 7 over 6. Now we want to find the exact coordinate where this is true. So let's substitute that value in. We want to find the exact coordinate. So let's simplify this manually instead of using our calculator. This one will get us 9 pi over 4. Is it 9 pi over 4? Okay. And we know that we know that cosine graph, it will repeat after 2 pi. Right? After 2 pi, it just repeats. It's a cyclic or periodic function. So we can take away 2 pi from this graph, or this function. So we know that cosine 4 pi over 4 is the same as 9 pi over 4 take away 2 pi, which is pi over 4. And pi over 4, we can use the triangle to sort out this, right? It's the 1 square root 2 triangle, where each of these angles is 45 degrees. 45 degrees, that is pi over 4 radians. So cosine 45, you have adjacent, which is 1 over hypotenuse, that is square root 2. So I'll replace this as negative 1 over 3, 1 over square root 2, and 7 over 6. And okay, now we just have to rationalize this. So I will multiply here square root 2 on the bottom and square root 2 on the top. Get square root 2 over 6, 7 over 6, which is 7 minus square root 2 over 6. So this will be the exact y coordinate. Question 9. The first term of an arithmetic progression is 9. T1 is 9. And the last term of this progression is 159. The sum of all these terms is 2604. Okay, the last term, I don't know what that is. So I'll just write the last term, 159. The 12th term, okay, there's more information. 12th term of this arithmetic series is the first term of the geometric progression. So geometric, I'll use U. And the 8th term of this series is the second term of a geometric. Okay, so this is all the information that we know. We want to find the sum of the first 6 term of the geometric progression. So I use this notation. N equals to 1, UN to 6. Okay, we want this one. How do we find this? Okay, let's try and break this down first. We know the sum of the terms is 2604, and luckily we have the formula for that case. Okay, first term and last term, and the sum of the terms, we can use this formula. So S of n, we don't know what's n, so n is the terms we want to find. We don't know how many terms is included here, but we know that the sum of these terms is 2604. So we can just use that information and to find n. 9 plus 159. So there will be 31 terms here. And we know that the 12th term of the arithmetic series. So okay, let's first formulate the term-to-term rule of the arithmetic series. First term is 9, and there are 31 terms. Okay, we still don't know the difference, right? We don't know the difference of the... Okay, but now that we know the number of terms, we can just, again, we use this formula to what we call find the difference. So T1 equals to A, or rather that's a bad term to use. T31 is 159. So the first term is 9 plus 31 minus 1, and D equals to 159. And the difference therefore will be 5. So now we can formulate the term-to-term rule. Tn, it will be 4 plus 5, 5n. T12, T12 equals to U1. T12 we can get as 64, and U1, they will give us AR power 0. So it's just A. So first, the first term of the geometric series is 64, and the second term is the eighth term of the geometric arithmetic series. So get us 44, which is equals to AR of 1. And so the ratio we can get as 44 over 64. Yeah, 44 over 64. Let me see if we can simplify this further. Yeah, so 11 over 16. Okay, good. Now, I think we're ready to find the first 6 terms. We have all the information we need. Yeah, here. Using this formula. So S6, what is it? A1 minus R6, 1 minus R. Right. So first term A, 64, 1 minus 1 over 16, power 6, 1 minus 1 over 11 over 16. And we get 183. Part B, a different geometric progression, has a first term of sine theta, so this is our A now. And the common ratio is cosine theta, where cosine theta is between these two angles, and show that it has a sum to infinity. For sum to infinity, if you recall, the requirement for that is the modulus of the common ratio must be less than 1. So between -1 to 1, not inclusive. Show that this has sum to infinity. So we need to show that cosine between these two angles will never exceed 1 or -1. So let's try and sketch the cosine graph out. 45 is here, and 135 is here. Okay, so here is 1, here is -1. So let's try and find what these values are and show that they are not, they are not reaching 1. Cosine 45, if we recall that we draw the triangle just now, 1, 1, square root 2, 45. So we know that this is 1 over square root 2, or square root 2 over 2. Cosine 135 is the same as negative cosine 45. Okay, you remember this relation. So negative square root 2 over 2. So cosine theta will be always in between these two numbers, which is fit this criteria. Therefore, S infinity exists. Okay. Part 2, show that this sum to infinity can be written as a trig identity like that. Okay, so we need to use this formula. A over 1 minus R. So S infinity, the A is sine theta, 1 minus cosine theta. So how do we deal with this? Okay, maybe we can multiply the top and bottom by 1 plus cosine theta, so that our bottom, okay, this A minus B, A plus B, you get together, so it's A minus cosine square theta, whereas on the top you get sine theta plus sine theta cosine theta. Okay, on the bottom, this relation, using the Pythagorean identity, sine square plus cosine square equals to 1, I can rewrite this as sine square theta. And on the top, we just leave it. Okay, now we can separate the fraction out. Here I get 1 over sine theta plus cosine over sine. And we already know that 1 over sine, that is the reciprocal of sine, so that will directly can be as a cosecant. Cosine over sine, that is 1 over tangent. Okay, tangent is sine over cosine, so 1 over tangent is cosine over sine. 1 over tangent, reciprocal of tangent, we can rewrite it as cotangent. Okay, so therefore we have shown. Question 10. Kinematics question, sorry, not kinematics, but a vector question. Time is in seconds, speed is in meters per second. So from 0, P starts from a point and travels with this speed in this direction. So find the position vector of P at time t. So let's first find the velocity vector. So we know it travels in this direction. So something like that. 20i plus 21j. And this vector has to have a magnitude of 58 meters per second. And it starts at 30. Okay, so let's try and find the unit vector of this directional vector first. So the magnitude of that, or the okay, let's find the direction unit vector. You just take the direction vector 20i plus 21j, divide it by the magnitude. So the magnitude using the Pythagorean identity, 20 squared plus 21 squared. So we get 1 over 29. So I'm not going to simplify this first. And the velocity vector, since now this will have a unit unit or magnitude of 1, we just have to multiply by 58 to get a magnitude of 58. So 58 over 29, 20i, 21j. And this so happens simplify to 2. So we can expand this like that. But not finished yet, because we need to know that, or we need to remember it starts at this point, and this is the velocity vector. So this depends on time. So our position vector, okay, position vector OP will start from negative 30j, adding with 40i plus 42j multiplied by time. So this is the velocity vector times time. And this is the original starting point. Okay, so this will only be the final answer. Part B, also at time 0, another particle starts from a position vector of this point, and it travels with a speed at an angle theta alpha above the positive x-axis. So the direction is this way also, where alpha is here, where tangent alpha is 7 over 24. So okay, we know that it's going to be a triangle like that. So tangent, we know opposite, which is 7, adjacent, which is 24. Okay, and so we can find, the direction vector is 7, or sorry, not 7, 24i plus 7j, because it's going to the right and going upwards. Okay, so the unit direction vector, that will be 24i plus 7j divided by the magnitude of that, which give us 25, 1 over 25, and the entire vector. And so the direction of velocity vector, again, we need to multiply by the magnitude. This is the magnitude given the speed, right? So 75 over 25, that's just 3. So expanding, yeah, we get this. And we want to find the position vector of Q. It starts from this point. So negative 10i plus 18j. So this is the original starting point. Then we need to add the velocity vector multiplied by the time. Okay, so this is the position vector. So determine whether they collide or not. Yeah, so to determine whether they collide, we just have to equate these two vectors. So if collide, then OP will be equals to OQ, right? So maybe to make it more convenient, I'll write it as a column vector. So OP, we have 0, negative 30, plus. So yeah, let's try and solve this. in the I direction, we can equate 40t and 72t minus 10, which t we get 5 over 16, and in the j direction, we hope we get the same answer. If they do, that means they do collide. So yeah, from these two equations, the t values do not match, so they do not collide. So this shows they do not collide. If they do collide, these two values will be the same. 11, given that n plus 1 p5 divided by 437 equals to n p3, use an algebraic method to find the value of n. So if you recall, npr, what's the formula? Is n factorial divided by n minus r factorial. So yeah, let's try and put this into algebraic form first. So n plus 1 p5, n plus 1 will be on top, factorial. Then n plus 1 minus 5, factorial on the bottom, with 437 still here. Then we equate it to n factorial over n minus 3 factorial. Here, yeah, we simplify a bit. Okay, so I've rearranged it here like this so that it's easier to see how we're going to cancel out the terms. N plus 1 factorial, that is n plus 1 multiplied by n minus 1 multiplied n minus 2, and so on and so forth. N factorial, that's n multiplied n minus 1, n minus 2, and so on. So if we have n plus 1 divided by n minus 1, everything cancels out except the n plus 1, right? So here on the left hand side of the equation, we're just going to have n plus 1. N minus 4 over n minus 3. Again here, if we have n minus 4 and n minus 3, so n minus 3 on the bottom, and everything else is cancels. So 1 over n minus 3 here, and still we have 437 on the numerator. Now we have a quadratic to deal with. So n plus 1 multiplied by n minus 3, then we can simplify this. Okay, after simplifying and factorizing, we are able to get two values of n, which is n is 22 and negative 20. But we look back at our original equation, that is a permutation. So a permutation means obviously you're choosing something from something, where obviously you cannot choose from a negative number of things. So we're gonna reject this value of n, the negative 20, and only one answer, 22. Question 12. A function is defined by this trigonometric mess for x between negative 0.3 and 0.5 in radians, and we want to solve this equation to be equals to 0. Okay, so first thing, I'm gonna put this cosine square term into a sine square, 1 minus sine square, using the Pythagorean identity. So cosine square equals to 1 minus sine square. Then now, yeah, everything will be in terms of sine. And I'll even directly equate it to 0. Okay, so right now we have gotten as a quadratic equation in terms of sine 3x plus 1.5, and we need to factorize it. You should be able to get sine equals to negative 1 over 5, and then also equals to 3 over 2. Okay, 2 over 3. So now we only start to solve for the trigonometric values. So first of all, let's change this range into 3x plus 1.5. Okay, so now we know that 3x plus 1.5, instead of looking at the x value, we can look at 3x plus 1.5 in between these two intervals. And okay, let's start with the negative 1 over 5 case. So it's negative, so we know it exists in the third and fourth quadrant. And we can get the basic angle. Remember, your calculator is in radian. Basic angle 0.201. Okay, so we want to find in the third and fourth quadrant, here will be 0.201, 0.201. In the third quadrant, the answer we should be able to get pi plus 0.201. Fourth quadrant, it will be 2 pi minus 0.201. Okay, so immediately you notice that the numerical value of these two answers is greater than the allocated range already. So unfortunately, we have to reject both of these answers. And we also don't have any answers in the negative quadrant because they will straight away go into the negative, which is also outside of this range. So yeah, we move on to the next case, which is 2/3, and it exists in the first and second quadrant because it's positive. Okay, so the basic angle alpha, we get 0.7297. And yeah, since it exists in the first and second quadrant, we can directly take 0.7297 as the first answer. And then for the second answer, we take as pi minus 0.7297 in the second quadrant. So yeah, these two answers fall within the range that we have established, and we can simplify this further. So yeah, we only have two answers in this question, which is negative 0.257 and 0.304. And we want to find the x-coordinates of the two stationary points on this curve. Okay, if we recall, for stationary point, the condition is that the derivative equals to 0. So let's take the derivative and equate it to 0. Maybe I copy down the equation first. Okay, then we can start the differentiation process. Cosine square, first we differentiate the entire function, which is becomes 2 cosine, right? Minus 1 from the power and take down the power. And then the chain rule, we have to multiply by a negative sign, okay, differentiating the cosine, negative sign, 3x plus 1.5. And then we still need to multiply the 3 from the inside function. So 3 chain rules here. Next, 7 sine 3x plus 1.5, that will just be 21. 21 because the inside function is 3x, so we need to derivative and multiply that. 7 times 3 is 21. Sine differentiate, you get cosine. 13 will be gone because it's just a constant value. And we equate the whole thing to 0. And yeah, let's simplify this a bit. Okay, after simplifying, I think we can able to factorize some stuff out, right? So there's a cosine and a cosine, and think we can get the multiple of 3 out also. So we can get a 3 cosine out of the entire equation. After you factorize, finish, and solve for this, you should be able to get two cases where cosine 3x plus 1.5 is equals to 0, and also sine 3x plus 1.5 equals to 7/30. So let's deal with this cosine first. We know that cosine equals to 0 when the angle is pi/2 or is 3 pi/2. But 3 pi/2 is probably outside our range already, which is 3, yeah. So we can probably only take pi/2. And we check back with our original domain here. X is included from negative 0.3 to 0.5. So yeah, therefore this fits the range of x, and we can accept the answer. And we're going forward to the sine part. We know that it exists in quadrant 1 and 2. So we find the basic angle first, and 0.236. For the first quadrant answer, first quadrant, you can just directly take the basic angle. And then for the second quadrant, you get pi minus 0.236, right? So 0.236 itself, it is outside of the range. Yeah, less than 0.6 already. So we need to reject this. And we are left with just the pi minus 0.236, which is 2.91, which is yeah, which is less than 3, and therefore it fits the range. And after simplifying or solving, you should get 0.469. So you only have two stationary point. Yeah, as it mentioned in the question, right? You should have two stationary point for the x coordinate only. So that's it for this question. Lastly, solve this equation. Okay, so we can notice that 64, it can be represented as a base of 2. So 64 is a 2 power of 6. So let me just write that down first. We just multiply in the powers. So okay, now it gets a bit more obvious to see that we could take away this plus 2. Okay, remember this. If there is a adding of powers is the same as multiplying by the same bases. Right, so I will split the power, becomes 2 power 6x multiply 2 power 2. And this 6x, I can rewrite it again as 2 power 3x and then square it. From this exponent rule, if you have a power to another power, you can multiply the powers. Okay, so 3 times 2, that is 6. Or 3x times 2, that is 6x. 2 power 2, that's 4. And so on. Now we have a quadratic in terms of 2 power 3x. And we should factorize it. Okay, after factorizing, you should be able to get 2 power 3x is 3 quarters, or 2 power 3x is negative 1. So obviously 2 power of something, it cannot be a negative number, so this one has no real solutions, right? And for the second part, I mean this scenario, 2 power 3x equals to 3 quarters, you just take the log base 2 on both sides, and then we can solve 1 over 3 log of 3 over 4 base 2. Then I think you can type this in your calculator since they did not ask for exact values. And yeah, 0.138 should be the final answer for this. Okay, that was the final answer, and that concludes this paper. Hope you learned something. Thank you for watching.